Alright, let's see what this assignment over winter break is. How old is Earth? Let me Google that real quick. How old is Earth? First result. 4.543 billion years. Alright, now I guess the rest of the video should just be a black screen. Oh, you're still here? Well, if you really want to know how we actually got here, I can explain. Our whole universe was in a hot, dense state, and nearly 14 billion years ago, expansion started. If you keep going like this, you will fail this assessment, and this entire class. Wait, how do you know? Take a guess. Fine. I will take this more seriously. But in actuality, the universe did in fact start with a hot, dense state. This became known as the Big Bang Theory. No, not the TV show, but the creation of the universe. It creates many particles, or electrons, neutrons, protons, those shenanigans, and this makes them gases, including hydrogen, helium, oxygen, carbon, nitrogen, silicon, magnesium, neon, iron, and sulfur, which are the top 10 main gases in the sun, based on NASA's Goddard Space Flight Center. The main two are hydrogen and helium. So eventually, over time, these gases condense. Within this creation, a star is formed. When a star, in fact, dies, that means it explodes, or a supernova changes it into a floating gas, or a solar nebula. These gases also condensed until we got what is known as the sun. From the sun's gravitational force, planetesimals, created by the supernovas, orbit around the sun, eventually become the planets today. One of these planets included the Earth. Hello, my name is Austin Ju, and rather than how old is the Earth, how did we figure it out? Earth rocks, moon rocks, and meteorites. First, Earth rocks. They are more valuable to researchers than you may think. Scientists were able to use radiometric dating and half-lives in order to calculate the age of the Earth. A half-life is, quote-unquote, one of the 3 basic principles of radiation exposure, end quote, and is, quote, the time for a quantity of radioisotope to decay by half, end quote, according to the Division of Environmental Health. Put it simply, there is this cool thing called an atom. It makes up like everything in existence, and they were made from varying amounts of protons, electrons, and neutrons. When they have become unstable, they have to decay at some point through alpha, beta, or gamma decay. Because of the decay being exponential, or every half-life cutting down the amount of materials remaining by half, they can use it to calculate ages. With this method, scientists use the decay of carbon-14 to nitrogen-14 as their clock in order to find ages. As the age for said decay is approximately 5,730 years, they've used the calculations to date objects to calculate fossils, ancient objects, and rocks. These are comparing the decay of carbon to the ages of other products. This is known as radiometric dating. This, however, is limited by the fact it can only go up to 55,000 years old. For older objects, scientists use the half-lives of uranium. According to National Geographic, the oldest rocks being found on Earth are estimated to be 3.8 billion years old, while some tiny materials were up to 4.2 billion years. These were rocks from the oldest rocks found on Earth. The problem with using radiometric dating on rocks on Earth is the constantly changing forms of rocks. It's difficult to find how old the rocks on Earth are through weathering, melting in plate tectonics, and erosion. That's where our friends the moon rocks are able to be put in play. Within space, the rock cycle on Earth doesn't apply. Plate tectonic movements which cause earthquakes and can melt rocks to perform them? Nope. Weathering or erosion over time? Nope. Apollo 11 and Apollo 14, which are space missions to the moon, brought in rocks from the moon to research. They were able to be found and shown up to ages of 20 million years from the Apollo 11 space mission, with the ages being 60 million from Apollo 14. These showed that the Earth was a lot older than expected. But that's not all. Meteorites may have even come from asteroids or even smaller planets from the original formation of the solar system, theorized with the heavy bombardment theory. This theory states that when the solar system was being formed, smaller failed planets and moons crashed into the Earth and all the other terrestrial planets, with evidence being from the craters on the moon. These meteorites, along with our Earth's rocks and moon rocks, allowed us further to have the estimated age of the Earth, estimated at 4.5 billion years old. With the most reliable data being shown from meteorites and things from space, we can only get a very rough estimate of the age of Earth. Ultimately, the Earth is still an estimated age, along with other ancient artifacts, due to how half-lives work. But the estimate of 4.5 billion years is the closest we've got. The heavy bombardment theory is the answer to what and where these other planets that crashed into the Earth were, and we use the age of uranium to date the actual Earth. Now for my final question, when can I be done with this and when can I go to sleep?